All right, I can't really explain much on TikTok in one friggin' minute. All right, so I'm just going to explain some stuff here, like especially the black hole, what it is, and actually why it is. Well, what it is technically. All right, so you have the states of matter in the universe. Okay, I call this quantum thermomechanics because technically the second law of thermodynamics can be poked hole. I mean, it has a hole in it, big time. Okay, it states that heat is going to turn cold. Okay, but it had to get hot in the first place. So the laws of thermomechanics indicate, or I wrote that any source of heat in the universe is generated from a cold source. Okay, so any heat is always generated from cold. Everything in the universe. In fact, anytime any heat is ever produced, the surrounding area is colder. That's your potential difference. And whether it's a cigarette lighter, if I lit a lighter right now, it's hotter than the room is. A woman incubating a child inside her, the womb, the baby is hotter than the mother. Your core temperature is hotter than the surface of your skin. So no matter what it is, it's always hotter in the middle or in the core. Just throwing it out there, okay? All right, so instead of using the Big Bang to figure the universe out, we should have been using the nature of hot and cold the whole time. Now, thermomechanics isn't a cold body going to cold or a hot body going to cold. It's how hot and cold move in free space. Now, what we have on Earth in this effect is a tornado. You get hot and cold air that can move in free space, and it gets in a tussle and it creates a cyclone. Okay? Well, quantum thermomechanics work the same way. Okay? Anyway, so you have a spatial value. Now, a spatial value is how much space you have in between particles. Okay? We don't have this. In fact, physicists, for some reason, never measure space. I understand it's infinite. It goes infinitely large, infinitely small. It literally never ends. No matter how large, how small anything is, space literally just goes on forever. Okay? So instead of quantizing light like we have with the photon, we're going to have to quantize space somewhat too. Okay? So when it comes to gases, all right, I'm just going to have to read this, all right? Okay, like I was saying, you have three states of matter in the universe: solid, liquid, gas. All right, here's the gas. It has a spatial value of 0. All right, gas, star, loose plasma has nearly 0 space between the particles. It's got a +1 charge because it's plasma. It's energy. It has a spatial value of 0 and has a potential charge of +1. All right, analogous to a proton and a neutron similarly. Now watch, with the matter, it has a +1 charge, or a +1 spatial value. Bohr's law is an electron orbit around the nucleus, okay? It's how far the electron orbits around the nucleus. That's pretty much the space of the atom, okay? So I call that +1. That's the space in an atom. You got a +1 spatial value, okay? Now let me read this. Solid, planets, atoms of matter have a space value of +1, neutral charge. Spatial value +1, potential charge 0. So matter, I can't remember where I was at. Kids came in. All right. Spatial charge of +1, or spatial. Oh my God, I'm confused. All right. Spatial value. I got charge written here. The spatial value is +1, and the potential charge is 0 because it's neutral. If you touch matter, it's completely neutral. It doesn't hurt you. It's fine. See what I'm saying? So it's got a neutral charge. But gases, or stars, have a +1 charge. These guys have a +1 spatial value. These guys have a 0 spatial value, okay? Which makes them both neutral to each other, kind of like a proton and a neutron. Protons +1 charge, neutrons neutral. You know, it's neutral. It's 0, okay? So when it decays into a +1 and a -1, making it completely neutral again. So here's the analogy here of a proton and a neutron in a large scale, on a larger scale, more or less, okay? Now, hot stars move toward the cold, okay? Now, in thermodynamics, the hot is going to want to move toward the cold. Now, since this thing is a cold helium Bose-Einstein condensate, and it has a -1 spatial value, that means it's completely dense. There's hardly any, literally, there's like particles on top of particles. You know, they're so closely packed together that there's literally no space at all. The star has zero space, zero space, okay? This is even less than that, making it way denser than a star, okay? Just by logically thinking of physics, just physically, okay? Now, the fact that Bose-Einstein condensate and liquid helium, or helium technically at 0 Kelvin is a Bose-Einstein condensate. Technically, helium is the only element that we know that can do this, okay? That's why, other than the fact that alpha particles and helium for nuclei are the same thing, other than that, that's what led me onto this track, okay? There's evidence everywhere. It's just like scientists look at things with numbers. You can't look at the universe with numbers. I understand that numbers, the universe is, but look, if you're going to be using numbers on the universe, you're going to be counting for infinity. So you're going to have to understand it fundamentally before you understand the numbers, or you're not going to understand where the numbers go. All right. So here, let's just go ahead and, okay. Liquid. Okay. It's liquid helium. It's dense liquid helium. It's a liquid. There's your matter. There's your gas. Okay. A black hole is so dense, it falls through matter or matter through it. Okay. Now, when we freeze helium, when we make a Bose-Einstein condensate, this stuff can literally fall through matter because it has no color charge. Okay. Now, technically, I'm just going to throw this out here. I'll explain it in another video. Micro anti-gravity is actually what gives us regular gravity. Okay. Micro anti-gravity is what gives us fundamental gravity. All right. Now, I know it sounds crazy. I'll explain it on a video. Trust me. Trust me. It's simpler than you would think. Very, very simple. So all of these stars are a lot hotter than this black hole. You know, even if it's freezing, even if it's friggin' negative 400 degrees, negative 360 degrees, regardless, this whole disk, this halo of galaxy around that black hole is hotter because of all the gas and stars and dust, okay? All of that potential difference is why all of that's getting pulled in, not to mention the density of it, okay? The gravity and the heat is going to move into the black hole because it's dense and it's cold. It's a superfluid. It's a quantum mechanical superfluid. Now get this. This is a misconception. People think it's a hole because it's called a black hole. It's not a hole. Here's an example. Here's a hole, okay? A real hole. Here's a hole. Now, if I put a hole in that, I can't do that. You can't put a hole in a hole and get something. You see what I'm saying? Now, since space is already a hole and a black hole is something, that means it's not a hole. It's actually something. It's made of matter. It's made of matter. And since it is so dense and black and dark and cold, the only other matter other than a solid or a gas it can be is a liquid. And any liquids that are Bose-Einstein are so, well, they're cold and so, I don't know, I want to say densely packed, but it's not exactly it. Basically, they're for reseeding, okay? Now, I'm just going to throw this out here, all right? Here's a galaxy being swallowed, okay? Here's the Bose-Einstein condensate. It's an X factor. It's a super cold superfluid, okay? Quark gluon plasma is at the core of it. That's a Y factor. That's super hot, okay? So you have an extreme potential difference here. Now, all of this matter that gets pulled in is literally going to be tore apart. It's going to go right through this and be demolished, okay? And once it goes to the core of this, it's going to become a quark gluon plasma, just like the singularity was at one point. This is a micro singularity, literally. What's inside a black hole and is emitted as a quasar is actually a small singularity. I know that's a theory out there, but scientifically we can prove that. We can prove that, okay? That can be actually confirmed, okay? So the YX, it recedes microcosm and then recedes, okay? Now here's another misconception. They say, oh, a black hole has infinite density. All right, look, black holes evaporate. If it had infinite energy and density, it wouldn't evaporate, okay? That means it has a finite amount that it begins to evaporate. You see what I'm saying? It's a misconception. So since they recede, after it recedes, then it will evaporate after it's done doing its business. Because that's what a black hole is for. It's a mother force, okay? And it's there to literally reseed the universe. Because once everything reduces back to ashes, all of that light that was emitted is still nuclear particle. It's literally still energy, and it's floating around. Now, I'm going to go ahead and read this. Microsingularity can only expel its heat as light because it can't explode. So it sheds until the plasma has receded. Then the black hole will evaporate. Okay? The thing is, it's like a micro-Higgs boson. The thing is, it can't blow up because it's in this black hole. It's so dense at the core that if it wanted to blow up, it would have to blow up, but it can't expand. All it can do is literally dissipate. And as it gets hot, it's going to emit Hawking radiation as it sheds its heat, and a quasar will emit. So there's always a potential difference. You have to look at the universe with hot and cold, quantum thermomechanics. Thermodynamics can be used, but the thing is with dynamics they are a body that gets hot and cold, not cold and hot moving in free space. You see what I'm saying? Quantum thermomechanics is actually quantum electrodynamics, quantum chromodynamics, unified field theory, quantum physics, and quantum mechanics all combined. I'm just saying. I'm just saying that cold fusion is how the universe works, literally. I mean, it's not like the singularity was just hot all of a sudden, it was always hot and then just all of a sudden got cold, okay? It was cold in the first place, it got hot, and then it got cold again. Or it was cold, then it was warm, then it was hot, then it was warm again, then it was cold. But the warm is right now. See, even the universe has a body temperature of 4.67 degrees. It's minus 455 degrees. Absolute zero is 459. That's on the outside of what would be our universe. So our universe has a body temperature. And infinitely cold does exist too, the further from the universe you get. Because technically, our universe does have a heliopause around it, similar to our solar system. There's a heliopause, or analogous to a heliopause. See, imagine this is our universe. And this is the whole it's of space that it's in. And it feels the weight of that universe. So there's going to be a bending around it. And plus the heat from the universe, even though it's very, 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 very cold out here, it's still going to be warmer than it's going to be out here. You see what I'm saying? It's just going to get infinitely cold. All right, so it's going to be, the singularity is going to go from a hot or a cold to warm. Then it's going to be burning up. Then it's going to big bang or blasticize like a zygote would do in 6 days, technically. And then once it starts reverting back to ashes, it's going to go into a warm state, which is what we have now. Now, we know the universe is very cold, but technically matter is warm nuclear and electric energy. It's almost frozen. It's not cold to the touch. It's completely neutral. It's warm, temperatured energy. It's not hot and it's not very cold. It's just right. And that's the Goldilocks zone of the universe that we live in now. So our universe is technically a carbon-based organism. It's literally a macrocosmic carbon-based organism, okay? Quarks are based on, well, ash. Quarks are point particles. They're the only thing in the universe that's self-born. So that's nuclear energy being born, okay? Now, that's alpha decay. Alpha decay and nuclear decay are how we measure the age of something. That's how we radiocarbon date. So literally radiocarbon dating, nuclear decay, alpha decay here, this is what indicates to us that we are living in a carbon-based universe, a carbon cosmic universe. All right, so I'm going to throw this out here. All right, so since it's carbon-based and the singularity will form, okay? Now I'm going to cut all the steps that form a singularity on other videos. I'm just going from after, okay? Now, 6 will form hydrogen, helium, and lithium, okay? Lithium is the first metalloid, all the way up to 26, which kills the star. L-I-F-E, life. So in there, that's when you have life. All right, so the universe literally wants to, after the iron is killing these stars, it's like the universe is like, well, I'm going to evolve a little blood cell and create little biostars out of the iron. Since it's killing the big stars or the big suns, I'm going to create some little suns and call them man. And I think that's one reason the sun and the sun are basically the same word. So the phoenix rises from the ashes, birthing a universe. You have to look within to understand without, and you have to look without to understand within. All right, so I'm going to read some of this. Okay. Let's see. Unicellular superorganism, Earth, iron core, blood as iron salt water, iron saline, leukocyte. Okay. All right, so like I was saying on other videos, our planet is a blood cell. It's a leukocyte. You know, it's got magma, saline, salt water, whatever. It's the same thing. Iron, which composes 70% of our blood. That's basically what our planet is running on. It's the iron helping the magnetic field stay generated, which gives us life. Well, it gives us a sky. And we live in an oxygen atom solar system, essentially. So we're carbon, nitrogen based, that's 6 and 7, and then oxygen is 8. So it's like the universe is like, well, let me create an oxygen atom solar system with a blood cell planet and evolve a bunch of little blood beings that breathe oxygen. Now I'm just throwing this out here, the 6, 7, and 8. Carbon 12 has 6 neutrons. Carbon 13 has 7 neutrons. Carbon 14 has 8 neutrons, 6, 7, and 8. All right, now I'm just saying, on the germ cell, you have the endoderm, the mesoderm, and the ectoderm, okay? Now this would be analogous to the core, or the nuclear energy, which goes through beta decay and forms the electrical energy, okay? The germ cell actually mimics the singularity, okay? A zygote actually mimics a singularity, okay? Now, siphonophores are a group, it's hard to, okay. Siphonophores have individual cells that create one animal, okay? Each individual cell is a colony. It's a colony of cells that are all individual, but they all work together to run the body of the animal, okay? We have all the same cells. All of our cells in our body are analogous in the same way, but they have the same genetic code, and they all work together at the same time. You see what I'm saying? They don't work with each other to make something happen. They all work as a whole unit. A siphonophore will have one unit of cells that tell it to do something and need it to do something when they tell the other unit of cells, hey, well, we done all this, but you got to do this. And they're like, oh, okay, well, let us do this. You know, they work in a colony. It's weird. It's kind of like sponge in a way. But that's analogous to how this goes through beta decay. See, in a zygote, we produce daughter cells, okay? Keeps copying daughter cell, daughter cell, daughter cell, daughter cell, okay? On an evolutionary scale, these siphonophores are that beta decay, okay? If you imagine that everything in the universe does the same thing over and over, when it comes to evolution, the singularity is going to do the same thing. When it comes to the nuclear, the alpha, that's going to be the prokaryotic life. The eukaryotic life is going to be its Y and X, okay? But when it comes to evolution, every time an animal evolves, it mimics an aspect of the singularity. And even when it's being born or it's developed or conceived, so to speak, conception, that's exactly what the singularity is. It's conceiving a universe. It's conception through Y and X, the male and female, nuclear and electric. So technically, I'm just going to throw this out here. Nature of liquid matter is the first in the universe. That's cold. The nature of the gas matter is the second universe. That's hot. The nature of the solid matter in the universe, that's third. That's warm. So literally, liquids form first because of the cold condensate. The cold condensate. Okay, the liquids form first, which gave birth to gas. And then the liquids in the gas gave birth to a solid. Now, I'm just throwing that out there. It's just a theory. It's just what things indicate. Now, this is just what I believe, okay? If someone has a better theory, can debunk this, that's cool. Now, I'm just throwing this out here. Magma is analogous to myoglobin, okay? It's heterotetrameric. It has 4 subunits: liquid, base melt, crystallized minerals, rock, dissolved gases, okay? Saline, hemoglobin. It's analogous to hemoglobin, okay? It's like the planet. The planet has saline and magma. It's blood, all right? Now, it's tetrameric. It has 4 subunits: sodium, chloride, hydrogen, and oxygen, okay? Blood has 4 parts: plasma, white blood cells, red blood cells, and platelets. That's just a little ironic, you know what I'm saying? And you always got to consider the 1 and 0 aspect, because the neutron is literally 1 and 0. Oh God, I wish this phone would do something better. Okay, the 1 and 0, the neutral aspect, neutron, all right? It's not a coincidence that neuron and neutron are almost the same word either. I'm just throwing that out there, all right? Now, space is neutral, and so is a neutron. So it all comes from a neutral standpoint, okay, from the first quark. Once that first quark is born or pops into existence, space is literally off balance. So chaos theory literally enforces a universe, okay? Because space wants to re-neutralize. Once that first quark pops into existence, it has to re-neutralize. It's like, wow, now I'm off balance. Now I got to equalize this. How am I going to do that? Well, I'm going to make another quark. Well, that's still off balance. I'm going to make another quark. So it pretty much goes through a whole phase creating a singularity, which creates a universe to revert all the way back to ashes and dust as a 1 and 0. It's going to go through all of that just to get back to neutral ground state. But it can't go to ground because there's no ground in space. So what's it going to do? It's going to reach a minimal energy output where it cannot put out any more energy, and it's going to start climbing back up. And literally, that's why we have that multiple universe theory. Oh, maybe it's a big bang that happens over and over. That's very, very, very possible. In fact, I would say damn near 100%. All right, so I'm going to throw this out here. Okay, color charge. Color charge is when quarks are moving really fast inside a proton and neutron. Okay, that angular momentum keeps it from collapsing. Now you have an electron going around the nucleus really fast. That keeps it from collapsing. Okay, you have planets going around the sun. That angular momentum keeps it from collapsing. The moon goes around Earth. It keeps it from collapsing into the Earth. Stars are going around the galaxy. The angular momentum keeps it from collapsing. Technically, gravity, scientists will disagree, but I disagree with them. Gravity is the strongest force, okay? It's not the weakest. Gravity is the strongest, technically, okay? If it wasn't for micro anti-gravity, everything would collapse. You see what I'm saying? Atomic or quantum or small anti-gravity counters fundamental gravity. Fundamental gravity counters the macro gravity. You see what I'm saying? So the reason why we have gravity wanting to pull us down but not collapse everything is because on a subatomic level, we have anti-gravity countering it. You see what I mean? And I mean, I know it sounds weird, but it can be proven. And logically, this is... I don't even want to get cocky or anything. I'm just saying, I want to help people understand something really easy. The universe isn't hard. When I was in my astrology classes in college, they always said, look, you have to look at it with the simplest explanation. If you overthink it, you're going to get confused, you know? And scientists, physicists overthink this stuff. Either that or they just cannot see the bigger picture because they're looking at it with numbers. Now, I've explained it before, but I'm just going to explain. Look, if you have these numbers, 3, 6, and 9 over here, okay, you don't know that you're dealing with a bottle with some liquid in it, okay? This is a bottle. It's got some fluid in it, okay? Those are the measurements. You don't know that's what you're dealing with. All you have is the 3, 6, and 9, okay? So what is that? How can you determine what that is? You know, if you don't know what you're dealing with, how can you apply the numbers to anything? You see what I mean? But if you know you're dealing with the fundamental bottle with liquid in it, oh, well, now I can apply the numbers. And that's why scientists or physicists are confused with the numbers because they don't know where they go. It's just like evolution. Notice that the grandfather paradox applies in evolution, okay? If you look up the evolution of certain animals, they always pop into existence from nowhere. They always evolve off the screen. And then when you try to find that animal, you find another animal, and then it just goes into nothing. It literally just, when you try to find out the root of all the animals, they pop into existence. I'm just saying. That's impossible. Okay, they don't understand where everything goes because they look at it with numbers, and you can't understand the world with numbers because the world has meaning. Okay, you can't apply something that has no meaning to something with meaning and expect it to explain it off to you. Okay, you can apply it and use it with it, but it's not going to separate. It's not going to be diverged. The numbers are going to explain everything, and we don't have to understand it fundamentally. That's bogus. You have to understand it fundamentally before you can apply the numbers. I'm just saying. So I'm just going to throw this out here, okay? June 2020, Cold Atom Lab on the International Space Station in microgravity created a Bose-Einstein condensate, and atoms formed a halo around it, okay? Now, they didn't know how or why or any of this, okay? But I can tell you exactly what they did. They almost created a damn galaxy. In fact, the halo around this Bose-Einstein condensate or a black hole are all the particles analogous in that little halo. You see what I mean? They created a microgalaxy for a little bit. I'm just throwing that out there. So stars cool as they reach the center or closer to the black hole, becoming red dwarfs. This is one reason we have a lot of red dwarfs that are closer to black holes, because they're a lot cooler. Because over time, this black hole has absorbed a lot of heat. It's not the fact that, you know, they're old or whatnot. It's the fact that they're so close to this colder source that it's absorbing the heat from them as it's pulling them in. So they're going to eventually turn into red dwarfs. And that's why red dwarfs are so close to the black holes, the core of galaxies. That's one indication. I'm just going to throw this out here. The halo around our galaxy is 18 million degrees Fahrenheit. 18,666. Just throwing that out there. Like 1 mole is 6.02. The Planck's constant, 6.26. Now I'm just going to throw these out here. The sun, or a sun and the sun. Recede, recede. Whole, whole. Holy, void, pure. Birth, birth, where the land meets the ocean. Matter of time. Matter matters. It's just a matter of time. Time matters. You are the matter relative to the space. So scientists always forget, whenever it's a time and a place to meet, they forget that they are the matter. And that's why Schrodinger's cats, or the Schrodinger cats paradox, is in place, because they're not considering that. They never consider space itself either. When it comes down to it, they never consider space. Space, time, and matter cannot be created during the Big Bang because you cannot add matter to make space. Space predates matter and time. Matter and time are symbiotic because without matter relative to space, you cannot have time. I'm just throwing it out there. There's the physicists, like I said, if they don't understand fundamentals and they only understand numbers, it's only going to create paradoxes. You have to understand the fundamentals.